let's talk about how you can reuse some of your existing data, specifically 2D, right? And when to reuse it. So if you have existing 2D data, it's still useful. You can leverage it for your 3D data, and you can literally copy and paste sometimes some of this data into 3D and start, making that transition. You're going to want to be careful though. You're going to want to make sure that you identify the right parts or right components to bring in, and right designs. Usually it's going to be something that's static, right? That doesn't change very much. That's super helpful. There are some, caveats to bringing this data in. It's going to be, maybe simpler data as opposed to more complex. In some cases, it's going to be static data that sits in a library ready to use to assemble a much larger assembly. And so your final assemblies, your final designs might be a combination of library components being brought in, and then a few, fabricated custom components that build your overall design. In fact, uh, some of you contract manufacture. That means you don't design anything. You bring in part number one, part number two, you purchase those things and you assemble it in a unique configuration, and your engineering services, your design services are really what you're selling. Okay. So not a good fit for really complex designs in a lot of cases, and especially designs that are prone to change. So you'll find that, if you do bring this stuff in, you may not have designed it the way you normally would in 3D, and it won't lend itself to changing things, especially with automation. You might not put in the right parameters to quickly update for automation. So if you are considering, automating this process at some point, just keep in mind the static parts that don't change, possible to use in automation. But if parts are going to change, length, width, height, any type of parameters are going to constantly change, you're going to want to probably design that from scratch and design it with the sole purpose of automation. Okay. So with that said, let's look at this example of how you can do this. I'll walk you through this video, and we're basically going to look at, a assembly that's already been, transferred, from 2D to 3D, and specifically, how maybe we got this static component that we either purchase or it doesn't change very much. And we're going to go back in time and look at an AutoCAD file and bring it in. So first thing we're going to start with is just creating a brand new part. Right. So again, we're simulating the process to create that part and bring it in from 2D. And we're going to start with a brand new sketch, just like we normally do. Maybe your standards say, hey, the front face is always on this front XY plane. So we'll still do the same thing you normally do with 3D modeling, right? Assuming you've gone through some basic training. And there's tools that we can leverage here, an import tool specifically to bring in AutoCAD data. So when you open this up, you'll get a wizard that's basically focused on, bringing in AutoCAD stuff. It recognizes layers. You can turn them on and off, and you want to make sure that you only bring in what's necessary. So you're going to turn off layers you don't want, and also select the objects that you do want. So we're going to basically say we don't want everything, not that top right view. Instead, we're going to window around just the top and the front view. When we click next, we just need to verify that, it's reading the right units, millimeters, and we always want to constrain endpoints, right? You might apply the other geometric constraints, but I would advise not to, just because it may not do it correctly, not the way you would do it. So from here, we can move the data, right, and put it, closer to 0, our geometric center for the part. And, you'll see it's not fully constrained, and you could take a lot of time here to do that. And speaking of constraints, the dimensions came in as dimensional constraints. So we could actually click on them, and they're parametric. And you saw that whole change just a moment ago. Okay, so to fully constrain this, right, because that's a good practice, we're going to take another way. We're going to take another method, use another method to do that. So instead, what we're going to do is we're going to use these block tools that are available and create a block out of this geometry, right? We're going to name it. It's very similar to AutoCAD blocks, and we're going to select that front view. And when we click OK, that is fully defined. You cannot change the diameter of that. You cannot, take away the tangency points. But we do need to lock it down in space. So we'll add just a few constraints to lock it down in space. So this is now quicker, right? Because we don't have to constrain every single little thing. We're taking it and not changing it. Okay, so the top view we're going to keep around for one specific reason. We didn't extrude it, or we're not going to extrude it. We're just going to extrude that front view. And when we decide how deep to extrude it, we can reference that other dimension. So that's just a little piece of knowledge there you can take with you. If you do take other information, you can reference it. You can pick it from outside of that process. So now what's left is adding in more information like part numbers and things maybe into the properties. So that's a really basic example of how to get that part into an assembly and start reusing it right away without having to start from scratch, right? Copy, paste, extrude, and perform some modeling functions. So it's really a combination of the CAD data mixed with the 3D data. So in a more advanced example like this one's kind of taking the process to the limits, I'd say. So let's take a look at it. We're going to focus in on the bucket here in just a moment, but you can see a lot of these components were derived from 3D or 2D rather. And you could actually create separate parts, only include the sketches, and do kinematic studies. So we're going to focus on this bucket component and just give you an idea as to how this might work and use several sketches. So there's already one sketch there that was copied and pasted from AutoCAD. We're creating a brand new sketch. We're opening up AutoCAD directly from Inventor. And when you do that, you can just copy and paste directly. So as we paste it in onto this other plane, it's going to be in the wrong position or wrong place. And we're going to go ahead and just move it so that, in relationship to each other, there's a common datum point or common point that they both share. Okay, so we have a side view, we have a bottom view or top view, however you want to look at it. We're just going to use regular extrude tools and reference the 2D data, whether it's on one plane or the other. We can pick the dimensions to create geometry. So if we expose the sketch, we can reuse it again and start creating all the other geometry. The gussets, there's a number of gussets that are going to get created here. We could also create other types of geometry like work planes and still reference the points in the sketch or the dimensions on the sketch to locate them. And once you do, reference them, that's how you control them, right? So we're going to extrude from plane to plane to create, more gussets here. And you'll notice that they're fairly chunky and big. We'll refine those as we go. But in each of these new pieces of geometry, we're creating new bodies, and we're working in a part environment. So it's important to note that, hey, this is one part, even though technically it could be an assembly. And if it's static, right, this is the best way to handle it. There is a process or a way to, bring this to an assembly level and explode it as you create different bodies. But for right now, we're just going to bring in one last sketch, and we're opening up AutoCAD again, pasting into another plane where we created a sketch plane. Okay, so the details on how to do this, we've got tons of videos, and that's what we're gonna, send you links for. But again, we're extruding maybe another side plane here to create more plate geometry on the side, and of course the bucket teeth are going to get extruded there and reference a dimension from that side sketch. So in the end, what's left is, creating more bodies to represent each and every individual component. So in a single part, you could turn these on and off. And like I said, there's a workflow where you can explode this and turn each body, right, each one of these extrusions into its own individual part and an assembly that contains them all. Okay, so now what's left again is adding, the information that you normally don't have in 2D: colors, decals, part numbers, even, material properties. Is this made out of steel? So once you have this, you can see we've got to this fairly quickly. The unedited video of somebody doing this took about 12 minutes. So it doesn't take that long to copy this data into sketches, into an environment where it can be reused right away. let's